So we've looked at integration by substitutions, but using much more complex functions. What we're going to do here, I've got a couple of questions for you. I want you to read the questions, pause the video, have a crack at them, and then come back and check your answer with the work, and I'm going to show you here. So here you go. So I've got three for you to calculate. Each of them takes a different form, but follows one of the formats we've covered in the last couple of videos. So pause the video and have a go at those. So the first one, the integral of x times the square root of 2x squared plus 1 dx. Now remember, this is the one where what we do is we set our u equal to this part here under the square root. So in this case, u is going to equal 2x squared plus 1. What I can then do is take the derivative of this with respect to x, and I get du by dx equals 4x. Shift it across, and I get that du equals 4x dx, and then take the 4 across here by dividing over, and I get that 1/4 du equals x dx. Now the reason I've done that is I've got an x dx here. So what that means is I can get rid of that part of the integral when I substitute in for the u. I can get rid of what's under here when I substitute in for the u as well. So what I end up getting is the integral of the square root of u du times the quarter that's there as well. So if I then write that all in terms of powers, what I end up getting is my integral is a quarter times the integral of u to the power of a half du. Now that is a lot more straightforward to integrate than this. So if I follow the basic rules of our integration with the powers, I get 1/4 times u to the power of 3/2 divided by 3/2, and then plus my c, my constant of integration. If I then simplify all this here, what I'll end up getting is a quarter divided by 3/2, so it's the equivalent of a quarter times 2/3. So what I'll end up getting for that is 1/6 u to the power of 3/2 plus my c. Then substitute back in for u, and I end up getting 1/6 brackets 2x squared plus 1 to the power of 3/2. There you go. Don't forget your plus c as well. So there you go, that's the first integral done using one of those variations that we covered in the previous videos. Second question was I wanted to calculate the integral of sine squared x cos to the power of 5x dx. Now remember, this is the one where you look for the odd power and then you pair up a part of that with the dx so that when you do your substitution, you can eliminate a little bit of that. Now my odd power is obviously to the power of 5 here, so I'm going to rewrite this as the integral of sine squared x cos to the power of 4x times a cos x dx. So I've paired up a cos x from the power with my dx there. What I'm then going to do is say fine, so what I'm going to do now is let my u equal the first part, which in this case is sine x. So if I let u equal sine x, what I can then state is that du equals cos x dx. So now that I've got that, du equals cos x dx, I know that I've got this bit here, which I can eliminate, and I can eliminate the sine squared x. The only issue I've got is this cos to the power of 4x here. Well, cos to the power of 4x, that can be written as cos squared x all squared. Now we know cos squared is the equivalent of 1 minus sine squared, so that's the same as saying 1 minus sine squared x squared, and I know that sine is equal to u, so I can substitute that in and rewrite it as 1 minus u squared all squared. So if I now put all these parts together in my integral, what I end up getting is the integral of u squared times the cos to the power of 4, which I'm now going to rewrite in this format here, times bracket 1 minus u squared all squared, and the cos x dx goes with a du. So I've now got it in this format here. So what I have to do is multiply all this out here so that I get an expression written in terms of powers of u, and I can then integrate it from there. So if I multiply out all these brackets here, what I'll end up getting is u squared take away 2u to the power of 4 plus u to the power of 6 du, and I can then integrate it term by term to see what I get. So starting with the first term, if I integrate u squared, what I'll end up getting is 1/3 u cubed. Next term, so 2u to the power of 4, that'll give me take away 2/5 u to the power of 5. I've then got plus u to the power of 6. Integrate that, gives me plus 1/7 u to the power of 7. And then don't forget your plus c, your constant of integration. So I'm near enough done. All I need to do now is get rid of the u by substituting back in here in terms of x. So what I'll end up getting is 1/3 sine cubed x, take away 2/5 sine to the power of 5x, plus 1/7 sine to the power of 7x, plus c, my constant of integration. So there we go, we've got it there, we've integrated it and got it back to that format that we want. It may occasionally ask you to simplify this, so you might have to take out a common factor and then use some of your trig identities again, but in this case I'm happy enough for us to leave it just like that when we've answered the question. Final one was the integral of the square root of 9 minus x squared dx. Now remember, for this one, this was slightly different because we did a substitution in terms of x equals something rather than u equals something. Now for this sort of one, got to remember, when we had the square root of a squared minus x squared, we used the substitution of x equals a sine u. So what I'm going to do is use that here. Well, remember the 9 is the a squared. We have to remember that is a squared. So if I take the square root of it, what I'll end up doing is use the substitution of x equals 3 sine u. Take the derivative again on both sides. I'll end up getting dx equals 3 cos u du. What I can then do is look at this here and see what I can get from that. If I was to substitute in x here for the x squared, what I'd end up getting is the square root of 9 minus the 3 sine u squared, so 9 minus 9 sine squared u. If I take out 9 as a common factor there, I'll end up with the square root of 9 times the square root of 1 minus sine squared u. So that's going to give me 3 times the square root here. Well, remember, using our trig identities, 1 minus sine squared is cos squared. So it's the square root of cos squared, so that'll give me 3 cos u. So what I can now do is take this and this part here and substitute them back into the original integral. And what I can rewrite my integral as is 3 cos u for the square root part here, then times the dx, which is then times 3 cos u du from that. Take this and put it all together to simplify it. What I'll end up getting is 3 times the integral of cos squared u du. So I've now rewritten it in that format there. Now the issue I've got here is that I don't have a sine u. If this had been cos squared u sine u, I could use a substitution to get rid of the cos u, get the derivative sine u, rewrite it and integrate it easy. But I don't have that in this case. So what I'm going to do is rewrite this here by substituting in for cos squared u. What I'm going to do is I'm going to substitute in a half bracket 1 plus cos 2u. So I can rewrite the integral as 3 over 2 times the integral of 1 plus cos 2u du. So now that I've got it written in that format, I can integrate this quite simply and straightforwardly. And I can rewrite it as 3 over 2 bracket u plus a half sine 2u plus c. So I've got it rewritten like that. The only issue now is it's something written in terms of u. We want to eliminate that, and we want to write it in terms of x. Now, a couple of parts we have to do for that. First bit here is use the x equals a sine u part. So in this case, we have to use the x equals 3 sine u. And what we can do then is rewrite that. So I've got sine u equals x over 3, and u equals sine minus 1 of x over 3. So I can eliminate the u here. Now the issue is I don't have something to eliminate the sine 2u with, because it's a 2u. So what I'm going to do is rewrite that, because I know that sine 2u is equal to sine u cos u. Now again, I don't have anything written in terms of x for cos u, but I know I can substitute cos u equals the square root of 1 minus sine squared u. So if I do that, I then get sine u times the square root of 1 minus sine squared u, and then I can substitute in, because I've now got an expression here for sine u. So what I can do is substitute that in, and I can get x over 3 times the square root of 1 minus x over 3 all squared. So I've got something now that I can substitute in here for the half sine 2u, and I've got something that I can substitute in for the u as well, and do a little bit of simplification for. So stick it all together. What I can then do is therefore write my integral, let's call that I, equals 3 over 2, bracket u, well I know that u is the sine minus 1 of x over 3, sine minus 1 of x over 3. It's then going to be plus a half times the sine 2u, so it's going to be plus a half times this. So plus 1 over 2 times x over 3 times the square root of 1 minus x squared over 3. So there we go, we've got it written now like that. Now that doesn't look very nice at all. We want to simplify it, play about with it a little bit, and actually make it nicer for us to work with. So what we're going to do in order to do that is multiply the 3 into the bracket, because what that's going to do, firstly, it's going to get rid of the 3 on the denominator here, but it's then also going to let me multiply into the bracket and see what I can get from there. So if I was to multiply through, I'd end up getting a half outside, bracket 3 times sine minus 1 of x over 3, plus, well, putting the 3 into there is going to get rid of the 3 on the denominator, so I'd end up with an x over 2 here, but what I've got to do is somehow simplify the 1 minus x over 3 squared. Well, 1 minus x over 3 squared, what that can be written as, if I'm going to just take it up here, just so I can write it all down. So I've got 1 minus x over 3 squared. That's the equivalent of 1 minus x squared over 9. If I was to take 9 out as a common, ninth out, sorry, as a common factor, I'd end up with 1 over 9, bracket 9, minus x squared. If I was to take that and substitute it into here for the square root and take that, I'd end up with the square root of 1 over 9, bracket 9, minus x squared. This 1 over 9 can be split off into its own square root, so I'd end up with 1 over root 9 times the square root of 9 minus x squared. So I can rewrite this little section here as that. We know 1 over root 9, that's going to be the equivalent of 1 over 3. So I'm going to get x over 2 times 1/3 times this square root. So what I'm going to get is x over 6 times the square root of 9 minus x squared. It's a lot of work, that last little step, but we want to make it look as nice as is humanly possible. And unfortunately for us, that's what it requires us doing. That's what it requires us to get to make it, ironically, look as simple as we possibly can. So there you go, a couple of examples of those techniques and how we'd work them through.